right. Hi, everybody. Welcome to this month's NEOWIT meeting. I'm Ellen Deeg. I'm the current president of the NEOWIT board. I'm going to introduce the other board members on the call. So Emily, wave Emily. She's one of the few people with is a board member. Deepa Rao is another board member.
Good evening, everyone.
We want to welcome everybody to our meeting. We are recording it, and it will be posted on our Facebook and some other places for anybody who wants to rewatch it later for any reason. I'll give one plug to our next NEOWIT event, which is August 18th. It's NEOWIT Book Club. Then the book is Testosterone Rex. So anybody that's interested, you still got time to read the book. And even if you don't completely finish the book, feel free to join the book club discussion about the book. We are always looking for new NEOWIT board members. If anybody would like to talk to Ellen, myself, Emily, or Deepa, we'd be happy to explain what that means. Basically, we look for people to help us plan these events. So I encourage all of you to be involved. And now we will get to the meat of tonight's meeting, which is Sarah. And I've already forgotten how to pronounce her last name. She just told me like 3 minutes ago. I'm going to turn this over to Sarah. And do you have, let's see.
See if you can make me presenter. I should be able to share at that point.
Let's try this. I'm making you a co-host, Sarah.
Oh.
Do you now have the ability to share?
I want to be able to share my screen and let's see if that works. So do you all see the intro to Azure DevOps?
I do.
I do.
Awesome. Awesome. And as you have questions, I will pause for questions at times. If Emily, if you see questions in the chat, could you stop me?
Yeah, I'll watch it.
Awesome.
Yeah, don't be afraid to ask questions. I ask plenty myself. Sarah knows that.
Yes. And I want to say thanks to Emily for reaching out for me. She's like, hey, can you speak? And I was like, let me know when you want me to come speak. So my name is Sarah Dutkiewicz. I go in the community by Sadukie. So the last name is a little bit of a crazy long last name. I usually go by my nickname. I'm here today to talk to you about Intro to Azure DevOps. What is Azure DevOps? What is DevOps? I know some of you from the 100 Devs community, so you're just new in your career in tech. And so these are probably new tools and new concepts. So feel free to ask questions. This is a very beginner friendly topic that I will try to answer them as best as I can. So the goal is I want to show you what is DevOps. We want to talk about the software development lifecycle. So what does that look like? And how does DevOps, the conversations that happen within the DevOps environment, what does that look like? We'll take a look at a sample. The sample that I have for tonight is something that you will be able to do on your own outside. I have a blog post that is scheduled for tomorrow that will break through these steps individually. So if you want to follow along with the blog post rather than the video, that's fine as well. And then we'll talk about some of the features of Azure DevOps as we go. So first things first, what is DevOps? So DevOps, think of it as cooperation and collaboration of not just developers, but the ops side as well. So we have IT pros, we have project managers, we have a few other players as well, but the IT pros and your project managers and your developers are going to be the three most common folks who are part of the discussions that happen in software development. The key with the whole DevOps is that everything is going to be continually delivering value. You'll hear things like continuous integration and continuous deployment or continuous delivery. So we'll take a look at what that looks like and how the Azure DevOps tools come into play for that. All right, so first let's talk about how does this general DevOps fit with the software development lifecycle. So here's your software development lifecycle. Notice that it is a cycle. So in most environments, you will have this kind of cycle where you gather the requirements for a project, you look at those requirements, you analyze them. From there, you can usually design the application, identify like how big of a project this is going to be or how small, maybe how many features are in the project, things like that. You have those conversations, that's usually your project managers, it could be your end users, it could be other business units, could be a combination of any of those. Your IT folks may be there just listening for ideas for infrastructure, perhaps. You may have writers, you may have QA folks listening for use cases. So everybody who has a piece in the development of it will probably also want ears in on the gathering and analyzing requirements part. It may have feedback in design. When it comes to building the application, that's where the developers come in and have to create the application. But then we have the documenting and testing, and that could be our QA, could be our writers, could be our developers, and then maintaining the application. Okay, now that we've got the first round in, we need to gather requirements for more features, and that cycle part. So our key players for the DevOps side, we have the IT pros, the developers, and the PMs. When it comes to working with the PMs, they're the ones who will help you define the initial scope. They usually are the ones who have to facilitate between developers and business unit. The business side, the non-technical side, the project managers are commonly that wall in between. Now, that said, should there be a wall between the developers and the end users? Probably not necessary, because your developers will probably have questions that get lost in translation. I've been in environments where I've had to play telephone between a project manager and the business and hope that we get clear requirements. But every time I've been in the field and I've been able to talk to my end users directly, I've had better success because we aren't playing that game of telephone. We're not playing the, oh, the business user said this, which I think might mean this other thing. And you're like, okay, what did they say? IT pros, what helps with having them in is that they can be the eyes and ears for infrastructure and making sure that, okay, is our system built to scale for the number of users using our system? Do we have enough memory? Do we have enough processing power? Do we have the right units here? So that's where the IT folks come into play. Well, like I mentioned, it's not just IT pros, developers, and PMs. You may have QA, the quality assurance team. If you get them in early on the gathering requirements, then they know what kind of use cases to expect. They know how to prepare their tests. They may even be preparing the tests as part of gathering the requirements and analyzing the requirements, so that then all they have to do is run the tests. Writers, those are the ones who are going to be documenting your application. Sometimes we're lucky enough that we have folks who can do the writing for us. Sometimes we're the ones who have to do the writing. Now with DevOps and the software development lifecycle, there are 4 main areas I like to call out. I like to call out the identifying the features. It's a conversation, it's a communications thing. So we need to be able to know what is in our application. Are we working on what's known as a CRUD application? So create, read, update, delete, the ever so not so secret recipe for most applications. Are we needing to store our data in a certain spot? For example, maybe you're working in an environment where you're dealing with credit card information. Do you have to worry about PCI compliance? How are you storing that? What do you store? Where can you store it legally? Compliance issues and things like that need to be thought of earlier, because the earlier you get ahead of that, the better off you'll be. So that goes into things such as identifying the features of your application and then also determining those tech requirements. So where can things be stored? What kind of things do you need? How fast do things have to be? For bandwidth, for storage access? Where are you storing your source code? And how is that getting versioned? That's a conversation to have early as well. Your application code, and you probably nowadays will also have infrastructure as code. And so you have to have that conversation with your IT pros and not just as developers. That's something I've unfortunately seen in the field too, where developers are like, oh yeah, we got this and we know the infrastructure and we'll build all of our YAML files. And then the IT pros go, this isn't going to work, but fine. And then when it crashes, the IT pros are like, we told you. In DevOps, communication is key. That whole cooperation, collaboration, working together to deliver value. You're one team working together for one goal, and that's to deliver the value. So play to each other's strengths and let the IT pros help with that kind of thing. Don't think, oh, it's code, therefore as a developer, I need to know this and I need to create the code. Not all code is the same. And sometimes it's easier to just defer to those who understand that better. Now, the main thing that I'll show activity-wise on the development side is the delivery of code. So I have a demo that I'm going to show tonight. And I'm excited to share. It's a basic like Hello World demo, but it'll allow you to get started and to give you an idea of how you can do this with your own applications. So as you have questions, please just post in chat and we'll answer them as best as we can. So Azure DevOps. Azure DevOps, the first way we access it is by going to dev.azure.com. So CTC, that is short for my company, Cleveland Tech Consulting. This is an organization that I have in DevOps. So the way we organize things in Azure DevOps is we have the general organization, think of that as your company. Then you have these things called projects. So I have tonight's demo that involves us tinkering with the code. And then one that's been already generated to give you an idea of what the generated code out there could look like. But I want to show you what happens. So you create a new project. When you have a project, you're going to create a project with a name. So I could say something like, I know our friend Emily here is working on a really cool app. So I could say something like Emily's app. And notice it says can't include an apostrophe. So it could be like Emily app. And I want to put in here, Emily is working on a cool app. Follow her on Twitter, something like that. Now, my particular organization currently is set so I can only create private repos. Companies can tell you you can have public or private repos. Now, if you sign up for your own account, you'll probably do a private repo. So, and let's talk about what that means for your private projects. So we have two things to consider. We have our Git or Team Foundation version control for source control. We will use Git. And then this work item process, we'll talk about what this is here in a minute. And then you would click create. Right, so from a high level overview, what this is going to allow us to do is it's allowing us to do project planning to start. So we have these things called epics, which are the biggest of chunks of a project. Then we have features, and then we have backlog items, and then tasks, which are sub items from there. Bugs, that's what happens when you have end users using your program and finding issues. And then other manageable chunks. So for example, maybe you have a CRUD application. So create, read, update, and delete. Your epic is creating my application. Features, so I might have a create feature. I might have an update feature, a delete feature, get all my items, and then get one item, and maybe search for an item. So now I have 6 different features. Well, each of those features are pretty big. I need to break it down into smaller chunks. And then I need to assign code to it and say, I wrote code. This is how it's delivering value. It goes to this. Yeah, so Emily posted in chat, does DevOps allow for better organization? It allows for better organization and a better way for you to demonstrate how you're delivering value. When you organize your project and the different pieces and parts, when you write your code and store it in your source controls, you can tie it to your work items or to your cards on the board. So you can say that my code delivers this value for this feature. So it makes it easier for project managers to say that the developers are working on a project. It makes it easier for the developers to say, this is how my code is delivering value. It also forces you to think about, okay, what is the code that I'm writing? Can I deliver value? Or is this something that I shouldn't be working on? Or is this something that I need to have a conversation with everybody else? So it allows you for better organization, better use of your time. It increases the communication and usually shortens some of the problems that you see with delivery. Now, Azure DevOps supports version control using Git or Team Foundation version control. We will be using Git. And then we'll look at pipelines and using continuous integration and continuous delivery. What's nice about that is that I can write code, I can check it in, and it can then automatically deploy it for me. And I will show you some of the examples that we worked with on that. Now, some of the benefits for developers, You can explain the value to your client because you can associate your code with work items. There's also code review abilities and change tracking. So let's say that, for example, I know Emily and Jacob are in the audience, and I know them from 100 Devs. Let's say that we're all working on a project together. Okay, Emily and Jacob, we have this hypothetical application and I want to add this cool feature. Here's the code. Could issue a pull request. They could look at the code and they can make comments like, Sarah, did you really mean to say that here? I think you spelled this wrong. You've created a function, but you're never calling it. So they could leave notes on my code in a code review. What's nice about that is they can make notes on my code, and then my code doesn't go into production until they've reviewed it and approved of it. I'm not releasing bugs into production without guaranteeing that people have, 1, reviewed it, 2, have commented on it, or 3, they may have just approved it and not commented on it. If they approve it without commenting it and then it's a bug, you at least have the accountability of who approved that pull request. And then you could go back to them and say, did you really mean to approve this? Because that was really awful code. Again, this allows you to automate your build and your deployment. So building is making sure that you can package your app in a way that it can run. And deployment is putting it onto systems that can then run it and host it for you. Tracking, see, Jacob has a question. Does GitHub let you do DevOps then? Sounds like some group projects he's done. Yes. So GitHub, you'll see GitHub projects is the equivalent to Azure DevOps boards. GitHub Actions is what you're going to see for Azure DevOps pipelines. So GitHub does have a lot of that functionality. Microsoft is putting documentation out there with GitHub. The demo that I'm going to show you where you can edit code, I also have links to the documentation where it's dealing with GitHub Actions. Tonight's demo plus my blog post will show you the Azure DevOps side of it. All right, so Tailwind Traders demo is a generated demo. The overview of a project allows you to see how many work items are created. You can see how many have been completed. If there are multiple authors, you can see that. This particular one doesn't have any pipeline set up. All right, so this is the summary. We're in the overview section in Azure DevOps. Now, dashboards are like high-level overviews of your projects. Then a wiki is good for dealing with documentation of your project. Let's take a look at boards and work items, backlogs, sprints, queries, and delivery plans, and see what's going on in there. So work items are various things that need to be done on a project. If we hover over the icons, there's user stories and tasks. User story is usually the big thing, and you can have multiple tasks associated with a user story. I'm going to just click on as a user. I want to add items to my shopping cart. That is the title. In this particular demo, they have their user story as both the title and the description. I'm going to collapse our menu here. So you're going to see the state of your work item. And then you can see in this case, it's our user story. It is active, which means that it is open to be worked on. The area, so you can break up your project into different sections and say that these features belong to this section. Maybe you have these features belong to creating an API. So this is like an API team versus data team, and creating the database and creating all the stored procedures or other data assets, for example. So you could set your area to specific areas like people and different responsibilities. You could see for iterations. So iterations are used for sprint planning. Okay, maybe every 2 weeks we need to meet and deliver X amount of work. 2 weeks is a common sprint period. So that could be what's going on here. So I have another question of, are user stories from managers or tasks you're assigned to? So user stories are what your project managers will usually create, or your business analysts. And they follow a certain cadence where it's I want to, and then there's some kind of action. So the user stories are usually the bigger piece of user functionality. The tasks are going to be the things that you usually work on. I'm going to use usually and probably, and I'm not getting too much into definites because some companies will use them differently. I am not one to be religious on how they get used, and I've been in companies that all use these tools differently. So there's the question of, does this have linkage for Epic's featured user stories? Yes, it does. So if I go to my details, it's harder to show on the little screen, but there's going to be a section here called development, and this will link your user stories. If there's code that they associate with the user story, it would appear here. The related work, notice that this, as a user, I add items to my shopping cart. It is linked to purchase. It also has 4 tasks associated with it. I'll notice purchase is a feature for this application. And then I can see all of the other things associated with purchase. If I scroll to the bottom right, there's related work. Notice we have 5 different user stories for the purchase feature. And the project management side of it all, this is where you're gathering your requirements, is where you're analyzing your requirements, is here in the board section. All right, so this Hello World sample that I want to show you, I'll show you what it's like to just bring in the repo. But why I like using .NET Core for demos is because it is cross-platform. And so I can show you what it looks like on Linux and then working on Windows as well. Before you can run the sample on your own, you'll need to create an Azure DevOps organization. And then if you end up using the pipelines, which I'm not going to cover too much tonight due to time constraints, you would also need to fill out this Azure DevOps parallelism request. Parallelism is one of those words I have to always slow down to say because we don't want to paralyze our code. We want to parallelize the code. We want to be able to run multiple parts of our code at the same time. This parallelism request form is you telling Microsoft, hey, I have this Azure DevOps organization and I want to be able to run my Azure DevOps pipelines in your hosted environments. It takes 2 to 3 business days. And I have a link in the slides that will give you more information about what the parallelism grant does for you and what the limitations are. For this demo, it's not going to require much. When you create your Azure DevOps projects, again, this is going into, let's show the work item process field, and then we'll come back to the demo itself. So when we're talking about work items, you can organize them in a few different ways. There is a basic, which I don't have outlined, Agile, which is what I use for the .NET Core demo. You can link them. We have epics are the big ones, then features are the smaller ones. In Agile, the backlog is the user story. User stories can have tasks. And then your bugs, you can either have a bug with a task or you can have an issue. But this is the terms that you see for Agile. Now, Scrum, on the other hand, instead of a user story, it's called a product backlog item. But they also have bugs and tasks. And instead of issues, they call them impediments. Functionality-wise, there may be different columns, but all the columns that I've shown you so far are customizable. Now, CMMI, this is called the Capability Maturity Model Integration. That's what CMMI stands for. It's a little more formal of a process, and due to its complexity, I won't be covering its flow, but just be aware that you can select it in Azure DevOps. Okay, let's talk about Git. So Git is the source control that we are using in Azure DevOps. The other is Team Foundation version control, but Git is more common, so that's why I'm covering Git. Now, when I first created my repository, first thing I noticed was that it was empty, and that's fine. I like being able to see this message. I'm going to import this .NET 6 Hello World repo. Now, when I do that, it comes with a branch of master. And so I want to create a main branch instead of master. And so what I end up doing is I go into branches, and I will show you what that looks like here in a minute, but you'll go to new branch, and you base your main branch off of master. And we set it as our default branch, and then we delete the branch. Going back to Azure DevOps, going to my Azure DevOps.NET 6 demo. So we're looking at the repo section. Now I've already imported it. This is some of the work I was doing earlier today. So when we do an import, it's your own copy of the repo. So these are the files that are in the repo that you had imported. We've got commits. With commits, we can see the Git graph. You'll see where Git comes from different branches, merging things into main. If you don't want the graph on, you can also toggle it off so you can just see commit messages. Then you can go into a commit. So if I wanted to see what's going on in this commit, I can click on here and you can see I got rid of some new lines. So nothing really fancy there. Privacy. So you can see what I've changed. So you can get into what changed for each of those commits. Then pushes are, of course, what did I push? You can see whether things were succeeded or failed in their deliveries, builds. So when I did the import, this is my copy now of that repo. This is the repo that we did an import from. So if I go to the commits here, I'm going to press Control N to go to the bottom, August 29th, 2017. So these are coming in from my import process. In terms of branches, so as my screenshot showed in the presentation, it had a master branch and we created a main and then got rid of the master branch. That just makes it a little bit easier for us for editing. You can tag your code so that you can say this particular tag is for this particular feature. We have this not set up in this particular demo, but in some of the generated demos, they have that. Then pull requests. So let's talk about pull requests. So I have none that need attention, but I want to show you completed. And we'll bring adding my superlinter in here. So there's a question about are tags also imported? Yes. With the pull requests, so there was a question earlier from Deepa about why would we use these pull requests versus GitHub pull requests. I'm going to say it depends on your environment as to which tools you use. I've been in companies where GitHub is their source control and they do the pull requests in GitHub. But I've also been in companies that have been dedicated to Azure DevOps or to Visual Studio Team Services, which is what its name was prior to this, or to Team Foundation Services, which was its name 2 times ago. If a company is fully immersed into just Azure DevOps, that's when I've seen the pull request feature used here. I also have been on projects where they use GitHub for the source control, they use GitHub for the pull requests, but then they use the boards feature in Azure DevOps because the boards feature is a little more fleshed out and mature compared to the GitHub projects, is how the client's opinion was. And so they use the GitHub integration. There's an Azure Boards integration that works with GitHub so that you can make Git commits in GitHub that can then be tied to your Azure Board work items. I debated showing that tonight, but I figured that was a little more complex than we needed. We want to stay in Azure DevOps. And so I left that part out. Now in this particular pull request, I can see what files did I change. I can see any of the changes that I made. In this case, what was added, that's my Git diff. I can see any updates. I can see my commits. I can see that it's completed. So pull requests are very much like what you would have in your GitHub repo. Now let me bring up slides because there's some other screenshots I want to show you with regards to pull requests. So branches, this particular screenshot shows multiple branches. This is for the Tailwind Traders demo. You can see when they were created, you can see how out of date they may be compared to the main branch. This example from Tailwind Traders, you can see that they have tags. If you click on the tag, it will take you to the code that's associated with that tag. With pull requests, you're bringing the code from one branch into another branch. This is especially needed if you can't push directly to a branch. So then what happens is you have to use a pull request. I used to work at a company where we developed in our what we call feature branches. So we name them whatever the feature is. Then we would bring them into our development environments. We'd have to do a pull request from our branch into the development branch. Then once everything was approved for development, then we would do a pull request from development into our QA environment. And once QA signed off, then we could do a pull request from QA into production. You can configure branch policies to say who can commit and who can't commit and what needs to be put in via pull request. You can set the approvals. You can say that code has to be tested before it goes in. Pull requests are very much configurable with what can and can't happen. One of the projects I was on, we had that you had to have 3 people review your code. You had to have work items associated with the code. That way the business knew what was getting delivered in the code. All comments on the pull request had to be resolved. That way there weren't just comments that were unaddressed. The build had to succeed. And then we also had code coverage, so identifying how much of our code was covered by tests. So there are tools in Azure DevOps and there are extensions that can be added in to help with that. Now, when it comes to completing a pull request, so you can determine how you're going to merge it in. and it shows the graph as to what it looks like in Git. If you're one of those who's more concerned about your graphs, when you change that dropdown, that will change accordingly. If there are work items associated to your pull request, those can be marked as completed automatically. You can check that box. You don't have to though, depending again on your company policy. Heading fix happened to be a branch that was getting merged, so I have the option here to delete it, and so that's why I said yes. Then you can also customize your merge commit message. So if you need to make any indications linking to other issues perhaps, that's where this customized merge commit message may come into play. What is a DevOps demo without actually demonstrating it getting deployed somewhere? Our code is going to Azure App Service. Now, why Azure App Service? First of all, it's my favorite app, Azure Service. Don't tell the rest of them. And yes, I know this is recorded and now I know that they're going to see this, but that's okay. Azure App Service, what I like about it is it's easy to start with, and it supports a lot of different, what they call runtimes and different operating systems. So I'm a polyglot programmer, which means I work with all sorts of different languages, PHP, Python, Java, .NET Core, JavaScript, Ruby. These are some of the languages I work with from time to time. Azure App Service has hosting environments for those. Also, it can do things on Linux. It can do things on Windows. It could do it in a Docker container. The .NET Core demo that I like using works both on Linux and Windows. So my screenshot here will show Linux, but I've also run this thing in Windows before. All you need is an Azure account. Once you have an Azure account, then you can create an Azure App Service. The Azure App Service also will create what they call a resource group. So that includes your app service, that includes your app service plan, which determines your pricing, and it includes your memory. There is a free tier. In my screenshot, you'll see SKU and size is the free F1 tier. I love using the free tier for demos because other people then can also play with it and not have to worry about the cost as much. And this region, you're going to choose a region that's close to you. This is my Azure App Service. I'm going to choose my resource group. This is Hello World, .NET Core, and I'll create it in Windows, just so you can see what that looks like. Now I need to say, do I want to do it via code, a Docker container, or static web app? We're not going to talk about static web apps or Docker containers tonight, but I do want to do a .NET Core. A .NET 6 LTS operating system. My screenshots show Linux, so let's create a Windows one, East US. But notice the app service plan is your location, your features, cost of compute resources. So I am going to tell it to create new. I'm going to call it my Windows App Service Plan. Tell it OK. I'm going to change my size. I'm going to come over to dev test because I want to show this and I want you all to be able to play with this as well. F1, notice I have 60 minutes a day for compute and 1 gig of memory. And this is the free tier. There are additional tiers, but I'm going to stick with the free one. They get into redundancy. We don't need to worry about that right now. And I'm going to go ahead and show you one more thing. Under deployment, I could enable this. So if I had a GitHub repository, this already has GitHub Actions integration already set up. We're not going to use that though, because this demo tenant is Azure DevOps. So I'm just going to tell it review and create. And create. So while that is creating, we're going to have our Azure repos for our deployment. I am in my Azure App Service on the Deployment Center. I've selected Azure repos. I tell it my Azure DevOps organization, my project, my repository, my branch, and I'm going to tell it save. And when I tell it save, what this is going to do is it's going to say, go to the Azure DevOps repo, go to the main branch, and then let's go ahead and deploy it. All right, well, that's doing that. What questions do you have so far? So now that this is hooked up, you can see what this looks like. It's going to connect to Azure repos. This URL here, this is using a webhook to connect to it. We're using App Service's build service to automatically build our code. We're not going to do a pipeline. We don't have the time to show that this evening. You can do custom pipelines. I will show you what that looks like later. I'm not going into detail, just to show you that it can happen. But if we go to my Azure App Service, you'll be able to see the code. I'm going to bring that up, but just so you're aware, behind the scenes, no tricks up my sleeve. Azure App Service does work well for continuous deployment. It uses something called Kudu, and it also uses something known as webhooks. So it's going to connect to your repo. It'll check for updates, and then it'll deploy based on when it sees an update. And just so you can see what this looks like in the deployment center. So in the deployment center, we hooked it up into our Azure DevOps. Now I'm under the log section, and you can see that it should have deployed successfully with that last commit. And I will pull over what it looks like deployed. You can see hello world from .NET 6. Notice on my slides that my screenshots were showing Linux, but we created a Windows host. Our host operating system here shows Windows. .NET Core works out of the box to work on both Linux and Windows, which is why I chose to show this as our demo tonight. So I didn't have to load Visual Studio and all my tools, didn't need to show that. Now we could say, hey, that .NET 6, we want it to be capital. The thing I just showed you was already capital because I was working on it, but we could create a new work item for that. When you create a work item, it's under new work item, then the list here depends on what you chose for your work item process. This is the Agile process. You could tell by this user story. If it were Scrum, that would be your product backlog item. And if it were CMMI, there would be a lot more options here. You can associate issues to pull requests. So earlier today, when I was fixing .NET to .NET all caps, you can see I associated that work item to my pull request. So I've got my Azure DevOps, and we're going into my files, and I am going to go under pages and under index, and I'm going to make an edit. Because I could come into here in this file section, and I could click edit and edit my files and commit. Or if I just click in the open area, I want to press period. Pressing period on my keyboard, notice that it's triggering Visual Studio Code. There it goes. This was a trick I learned with GitHub. When I saw it on GitHub, I was like, oh, that's pretty cool. Earlier today, just for grins, I was like, what happens if I press period here? And sure enough, vscode.dev. So Azure DevOps, that press period in the general repo area will take you into vscode.dev. I want to change this to say something like hello NEOWIT. Just so we have some kind of visible change. And we'll put another hard break or 2 or 3 in there. In Visual Studio Code, I have my source control. I'm going to go ahead and stage my change. I'm going to say changing my text, and I'm going to go ahead and commit it. Notice I can commit and push. I don't have Visual Studio or VS Code running on my desktop to show you this. I am staying right in the browser. This is the Hello World.NET Core Windows. I am in the logs. See the running deploy. All right, notice here we have success. We're changing my text. And I'm going to say refresh. Notice there's our hello NEOWIT. And you can tell we're on Windows because of our host operating system. I also have a Linux version of this. There it goes. Notice here's hello NEOWIT on our Linux one. Again, it shows Linux in the host operating system. It's the same code base. I only made that change in one spot, and you all saw me where I made that change. It's the beauty of .NET Core. And both of them have similar setups. The only difference is the operating system is Windows and Linux. All right, so we've looked at the key groupings. We've looked at overview. We've looked at boards and repos. We still have pipelines. And then we'll just barely touch on test plans and artifacts. Pipelines, this is where the automation and deployment part comes into play. So what you've seen so far with creating the app service and deploying, we're using the app service build tools. And what pipelines allows us to do is it allows us to automate the building of our code. When we use the Azure App Service build service, it's just going to build the code and deploy the code. It is not getting into anything like linters or checking formatting or things like that. I'm going to close the assistant over here, and I'm going to close the menu over here so we have a little more room so you can see what is a pipeline. This particular pipeline is a .NET Core pipeline. This trigger main means anytime code gets checked into the branch name main. And I have a step here for job lint test that is commented out, and I'll explain that here in a little bit. We'll come back to it. But then I have a build job. So what's going to happen is I'm going to use so where is the YAML? The YAML right now is it's stored in the repo. It's stored in this Azure-pipelines.yaml file. So it lives with the repository that is going to be building. And I've got right now, it's going to do the build configuration of release. And we're going to be using a Linux VM to do the build. And then I'm just going to call .NET build on my code and pass in that build configuration. And then I'm going to go ahead and publish. Now, the publish just gets the code in a spot where it can then be deployed separately. Now, why would you do this versus using the build service? The build service, again, it will build and deploy. With the pipeline, we have the ability to control. So maybe you have code formatting rules. That's where a linter comes into play. This is the super linter on GitHub. And this particular one, I have it where it's excluding the lib folders. I also have it so that it is only validating C# and CSS. So this is the pipeline. It could run a code checker when I uncomment this out. We could say that if the code formatting doesn't meet our standards, don't let it in our branch. This is where having a pipeline like this becomes helpful because you can get that fine-grained control. When it comes to releases, then we can take the outputs and then we can push that to a service. So it formats the code after someone pushes? No. So it's not pushing any changes to code. It's not formatting the code. It's yelling at you to format your code better is the best way to describe it. So I'm going to go to my pipelines and I'll go to one of the failed ones so you can see. Validate only C# and CSS dealing with linting issues. Let's go dealing with linting issues. So I'm looking at a past run of the pipeline that I know failed on purpose. Let me see if I can get into, there's the job lint tests. So I can check to see what was run. I can see that it failed on this particular step. And notice it says here, the file that it's checking, and this is a warning. So these are some of the issues it found. Things like your line is too long, it's more than 80 characters, or you need certain spaces. We expected this and we found this other amount. So linters, and there are various ones out there. I just chose super linter because it does all sorts of languages, but there are linters that are out there specifically for JavaScript or for CSS or for particular languages. So it could get language specific. Jacob, there's that question about formatting the code. No, it's yelling at you, or in my case, yelling at me. My license file didn't start with an H1. And so it tells me first line H1 is the rule. First line in a file should be top level heading. So it tells you what the rules are. The rules are configurable as well, but you can see what is it scanning, which file is it scanning. The super linter says which linter it's using for each of the files. I'm going to scroll up. I know there's some CSS errors just so you can see what those CSS errors look like. And this is the joys of DevOps, is there's a lot of logs. You can see here, it was expecting a new line after a comma. There's no end of line white space. Leading zeros are missing, color function notation. So linters are awesome for checking your code style, making sure that you're meeting certain guidelines, making sure your naming matches. There are various configurations that you could put out there, both standard configurations and customizable configurations. So that's what a linter does. And so when you have something like that, then you want to be able to create a pipeline using code, in this case, YAML. Then releases, again, is what would deploy them out. This allows us to say, I want to deploy, for example, when I push to main. Okay, that is my production branch. push it out to production. I could say to do it automatically, or I could say, hold up, I want somebody to approve it before it goes into production. So then somebody gets a notification, hey, we have something ready for production. Do you approve? Then they can click approve. In the environment where I first saw this was a two approval kind of process, and it was multi-factor authentication. So not only did I have to have people review it, but they had to use multi-factor authentication to truly approve it. So you can get very granular and control how you release things. So pipelines, think of them versus releases. Pipelines where you can run your linter, compile your code, run the code, package your code, and pipelines can deploy the code, but releases are what are better for deploying the code and being able to trigger them off of different conditions and setting approvals. You can't do the approvals part in your pipelines. That's where releases come into play. Environments allows you to work with virtual machines and Kubernetes. That's outside of the scope of tonight's presentation. It's a little more than an intro. Same with deployment groups. They're used for working with multiple resources, deploying to Azure and local resources. Test plans. I am running Azure DevOps on the free account, much like what you would be able to do. And so I don't have enterprise licensing, so I can't run any of the test plans. But the generated demos do have test plans, so you can see what it looks like for those. Artifacts is another section in Azure DevOps that I'm not demoing tonight because there's a lot more overhead to building it. It's not a simple intro topic. If you're working with things like NEOWIT in the C# realm, NPM on the JavaScript, Maven for Java, Python has its own package thing, and then universal package management resources. For Azure DevOps, ton of resources out there. They have YouTube videos, developer community, there's great documentation out there. The demo generator is what I use to generate the Tailwinds traders demo, but there are other demos as well. Microsoft Learn, if you aren't familiar with it, is a free learning resource. These particular courses are listed in order. That way you have their story straight. Azure App Service, that's what we use for our demo tonight. That deploy an ASP.NET web app. That's the repo that I worked with, but we also have Node.js for JavaScript. We have PHP, Java, Python, Ruby on Rails, and all of these demos deal with creating the app service like I showed you, though instead of using Azure DevOps, we use GitHub. And instead of pressing period in the repo for Azure DevOps, we press period in GitHub, and that takes you to the Visual Studio Code integration there. Other than that, they're very similar processes, getting started and not having to install a full-blown Visual Studio on your machine. If you're not familiar with Git, I know we have some folks new to tech. These are some of the sites that I recommend for getting started with Git and for understanding how to navigate Git. And then if you have any questions, I am Sadukie on Twitter, on LinkedIn, a data blog. This year, my goal is to do data science and data themed topics. All my projects decided to spite me, and so I'm on the developer side this year. So the dev blog is back as well. So you'll see blog posts from me in both realms, dev and data. What questions do you have?